Hello everyone, good evening. Hope you all are doing great. Guys, today we are going to learn third dynamic routing protocol, that is OSPF. And I must tell you, OSPF is very important routing protocol for all network engineers, right? Because OSPF is the protocol which we are using nowadays, in enterprises, in service provider network, in large ISP network, everywhere we are using OSPF protocol as IGP protocol. Okay, so it is very important. So try to understand very carefully. Okay, we will cover some basic points, some advanced points as well, and we will see the configuration part also. Okay, so topic for today is OSPF protocol. First of all, first thing about OSPF is it is a layer 3 protocol. Means this protocol works at layer 3. It works at layer 3. Second point is it is a link state routing protocol. It is an link state routing protocol. What do you mean by link state? Link state routing protocol will have view of entire topology, right? Link state routing protocols does not share routing table, right? It share link information, a state of link. Let's say we have one router and a router is connected with three interfaces, right? So router is going to maintain one database. Inside their database, it is going to keep the information of all links, and then router will share that in database to their neighbor. We will see how it is going to work. But link state means a link state router will have view of entire topology. Like if I will compare link state routing protocol with EAG, RP or RIP, because those are distance vector routing protocols. So those protocols are depend on their neighbor, right? All routers think that all routes are connected to my neighbor. Okay, because in distance vector, router does not have view of entire topology. But in case of link state routing protocol, a router can design entire topology by checking their database. Okay, so second point is it is a link state routing protocol. After that, third point about OSPF routing protocol is it has it maintain three types of table. First one is again neighbor table. Second one is database. And third one is routing table. Routing table. Okay, so these are some basic points about OSPF routing protocol. Now, let's say I have one router here, and this router is connected with one another router like this. Let's say this is R1, this is R2. Here IP address is, let's say, 12.1. Here IP address is 12.2, 12.1.1.1, 12.1.1.2. Fine. And this router 1 is connected with one LAN. Let's say here we have one switch. And router 2 is also connected with one LAN. Let's say here also we have one switch which is connected with R2. Let's say here we are running one network 10.1.1.0/24, and here we are running one network 20.1.1.0/24. Fine. So on this interface, let's say IP address is 10.1. On this interface, IP address is, let's say, 20.1. On this interface, let's say IP address is 20.1. So as you know, by default, 10 network cannot communicate with 20 network, right? Here we need to perform routing between router 1 and router 2. So either you can configure a static routing, you can configure dynamic routing, you can configure RIP protocol, you can configure EIGRP protocol. But today we are going to understand how to configure OSPF routing protocol here to exchange routing information between R1 and R2, right? So as I told you, router is not going to share routing table to their neighbor, router is going to send database. So first of all, R1 will have one database, right? Once I will configure OSPF and I will advertise this interface and this interface in OSPF, it will, keep the information of both links in their database like this. Link number 1, link 1. On this link, which network is running? Let's say 10.1.1.0 network is running. What is the subnet mask for this network? Subnet mask for this network is, let's say, 255.255.255.0. After that, what is cost on this link? What is cost on this link? In OSPF, metric is cost. OSPF is going to use cost as a metric. And formula to calculate cost is reference bandwidth upon bandwidth of link. We will discuss about that also. Just wait. So let's say cost on this link is 1. Then link type, which type of link it is? Let's say it is Ethernet link. Link type, Ethernet. In the same way, inside the database, there will be one more link information, link 2. Right, on link 2, what network is running? 12.1.1.0. So what is subnet mask for this network? 255.255.255.0. Right, cost, what is cost on this link? Means what is metric on this link? Let's say 1. And then which type of link it is, and there will be many more information. Okay, so we will see how database looks like. Fine. So this is database of router 1, and router 1 is going to share this database to their neighbor, means to router number 2. But if we have a full adjacency between router 1 and router 2, if we will have full OSPF adjacency between router 1 and router 2, then only router 1 is going to share this database to router number 2. So first of all, we need to understand how OSPF is going to form neighborship, right? So guys, in OSPF, there are 2 types of neighborship. In case of EIGRP, we have only EIGRP neighborship, right? Once we will enable EIGRP on router will start sending hello message, and both router will verify some parameters. If parameter will match, both router will become neighbor, right? And once router will become neighbor, router is going to exchange their database. But in OSPF, there are 2 types of neighbor, right? There are 2 types of neighbor. Types of neighborship in OSPF. Okay, first one is neighbor without adjacency, we can say neighbor without adjacency. And second one is neighbor with adjacency. Neighbor with adjacency. Okay, so OSPF router is going to share their database with adjacent neighbor only. With adjacent neighbor only. Adjacency, right? Only adjacent neighbor. Guys, without adjacency means they are only neighbor, right? They have not formed full neighborship. So if neighbors is without adjacency, that means neighborship is till two-way state. Till two-way state. And neighbor with adjacency means we have full neighborship. We have full neighborship. Full neighborship means we have already exchanged database. Actually, we have some, state of neighborship in OSPF. If I will talk about neighborship state, so first state is down state. First state is down state. OSPF neighbor states. First state is down state, down. Second one is init state. Init means initialization state. Then two-way state, two-way state. So never, maybe two routers will form neighborship till two-way state, right? Maybe two routers will form neighborship till two-way state. So in that scenario, OSPF routers are not going to exchange database. Fourth one is X start. Fifth one is exchange. Sixth one is loading. And seventh one is full. Right? So down state means we have enabled the OSPF on interfaces, but OSPF have not received any hello message, right? Once we will enable OSPF on the interface, definitely OSPF will start sending hello message, right? So down state means OSPF router is sending hello message, but it have not received any hello message, right? Once OSPF router will receive hello message, state will move to init state. And in init state, router will check neighbor router ID. Neighbor router ID means, whenever we will configure OSPF on router 1 and router 2. Let's say here we have enabled OSPF, and here also we have enabled OSPF. So both router will send hello message. Let's say this is hello message of router 1 and this is hello message of router 2. So inside the hello message, both router is going to share their router ID. Router ID is nothing but unique identification of router, right? In OSPF, how routers represent their database with the help of router ID. Okay. So in the hello message of router 1, we will have router ID 1.1.1. Let's say this is router ID of router 1. So router 1 is going to send their router ID in hello message. In the same way, router 2 will also send their router ID 2.2.2. Okay. 2.2.2. So both in the first hello message, both router will share their own router ID. But in next hello message, when router 1 will receive hello message of router 2, right? After received hello message, in next hello message, when router 1 will send next hello message, router 1 is going to share their own router ID as well and their neighbor router ID as well. Like my router ID is 1.1.1 and my neighbor router ID is 2.2.2. My neighbor router ID is 2.2.2. Neighbor router ID is 2.2.2. So once OSPF will see their own router ID in the hello message. Like when router 2 will receive this hello message, second hello message of router 1, it will see their own router ID inside the hello message. So once OSPF router will see their own router ID in the hello message, neighborship state will move from init to two-way. If router are not able to see their own router ID in the hello message, neighborship state will be still in init state. Still in init state. Just 1 minute. So state will move to init state when router will see their own router ID in the hello message. After that, state will move to two-way. In two-way state, routers are going to perform DR and BDR election. DR and BDR election. See, out of these two router, DR and BDR election will happen only in broadcast network. So we will discuss network type in OSPF also. So later on, we will discuss more about DR and BDR concept. But for now, just understand that in two-way state, routers are going to perform DR and BDR election. So see, maybe router 1 is going to become DR or maybe router 2 is going to become DR. Okay, so one router will become DR, other router will become BDR. If we have more than two routers, so one router will become DR, one router will become BDR, and rest routers will become DR other. And DR other and DR other is going to form neighborship till two-way, right? So let's say this router is also DR other, and router one is DR other, and router 2 is also DR. So OSPF neighborship will not move from two-way state to X start state, right? Only DR router is going to form, full neighborship adjacency with DR other and BDR. Okay, only DR router is going to form full way neighborship with DR other and BDR. Okay, DR other and DR other will have neighborship till two-way. Means two DR other router cannot exchange database with each other, right? Two, as I told you, because in two-way state, routers is not going to exchange database, right? Okay. Now let's say this router is DR and this router is BDR. BDR. So here neighborship state will move from two-way to X start. In X start, both router is going to, send one description of their database. One description of their database. First, it will send, like empty database. First, it will send empty database, and let me discuss types of messages as well in OSPF, guys. Types of messages. Let me show you types of message in OSPF. So we have multiple types of message in OSPF. First one is again hello message. Hello message. Hello message is used to discover neighbor and keep alive. What is the use of hello message? Neighbor discovery and keep alive. After that, we have second type of message, that is DBD. DBD stands for database description. Database description is like menu card of a restaurant, right? Inside the menu card, you will get the name of all food, but those are not actual food, right? Those are not actual. To get actual food, you have to order, right? So menu card is like description of that restaurant. That restaurant is providing how many types of foods, right? So description is in the same way. OSPF is also going to share one description of their database. Description of their database. And in X start state, router is going to send empty DBD, empty database description. Then if you are thinking, then why router are exchanging database description? What is the use of, if it is empty, then what is the logic of sending DBD, empty DBD? So OSPF routers exchange empty DBD to share sequence number, and for master and slab election. Like DR and BDR, we have concept of master and slab in OSPF. Means out of these two router, one router will become master and one router will become slab. The router who is going to become master will initiate sharing database, will start sharing, will send database first, you can say. Which router will send database first? Master router will send database first. Okay. So use of database empty DBD, empty database description message, just to exchange sequence number and master and slab election. Once both router will exchange DBD, state will move to exchange. State will move to exchange, and in exchange state, router are going to exchange actual DBD message. Actual DBD message. In this DBD message, routers will share header of database. Header of database, like router 1 will share database description to router number 2. That means I have 10 network and 12 network. If you need any network, please let me know. I will share you. Getting my point? So first router are going to exchange database description in exchange state. Okay. And then once database description will exchange between routers, state will move to loading. And in loading state, routers are going to share actual database. Actual database. Actual database. In which state? In loading state. And once two routers exchange database, state will move to full state. State will move to full state. Okay. Any question? And then if I will talk about messages, so database description, then we have LSR message. LSR means link state request message. Then fourth message is the link state update message. And fifth one is link state acknowledgement message. So we have 5 types of messages in OSPF. In access start state, router will exchange empty DBD. In exchange state, router will send actual DBD message. And after that, in loading state, router will share these 3 messages. right? Let's say router 2 need 10 network. So router 2 will send LSR message, link state request message to router number 2. And after that, router 1 will send LSU message. Through LSU message, router 1 will share 10 network information. And OSPF is reliable protocol. So whenever router 2 will get LSU message from router number 1, router 2 will send acknowledgement message. Guys, I'm getting some noise. Okay, so these are messages in OSPF.
How, sorry,
Yes,
sir,
yes.
how primary, secondary scenario is running active passive in OSPF?
Active passive.
Yeah,
I said master and slave and DR and BDR, not active
okay.
and passive. One router will become
Which,
master router
hmm,
who will have highest router ID. So in this scenario, router 1 router ID is 1.1.1, router 2 router ID is 2.2.2. So router 2 is going to become what? Master.
master. But we set matrix also, right, in this, in BGP?
Metric in OSPF is cost. And formula to calculate cost is reference bandwidth upon bandwidth of link. Cost formula to calculate cost is reference bandwidth divided by bandwidth of link. So let's say bandwidth of this link is 100 Mbps, 100 Mbps, and by default reference bandwidth is 100. So what will be cost on this interface? By default reference bandwidth is 100, and then bandwidth of my link is also 100 Mbps. So 100 divided by 100. Cost is going to be 1. Cost on this link will be 1. Clear?
Yes, yeah, thank you.
Okay. So let me design same topology here. Let's say I have two routers, R1, R2, and I have, let's say, two switch 1, switch 2. Okay, so let's say this is my topology. Between router 1 and router 2, I am going to use 2L network, 2L.1.1.0/24. Here we are running, let's say, this network 10.1.1.10.1.1.0/24. And here we are running this network 20.1.1.0/24, let's say. So first, let me configure this scenario. I'm going to configure the scenario from the scratch, guys. So if you will have any question, you can ask. You are free to stop me anywhere. Interface fast Ethernet 0/0, say no set, and IP address 10.1.1.1.255.255.255.0 exit. Interface fast Ethernet 1/0, say no set, and IP address 12.1.1.1.255.255.255.0 exit. Done. On router number 1, I have configured the IP addresses. Right? Do so IP interface brief exclude unassigned. We can verify the IP configuration, right? On fast Ethernet 0/0, IP address is 10.1. On fast Ethernet 1/0, IP address is 12.1. Fine. In the same way, let me configure IP on router 2 also. So config T interface fast Ethernet 0/0, say no set, and IP address 20.1.1.1 255.255.255.0 exit interface fast Ethernet 1/0, say no set, and IP address 12.1.1.2 255.255.255.0 exit. Do so IP interface brief exclude unassign. So here also you can see the IP configuration done. Now I am going to configure OSPF. And guys, before enabling OSPF on this router, I'm going to capture the link as well. Link between R1 and R2. I'm going to capture this link just to show you some messages of OSPF. Okay. So you can see, first of all, I am going to enable OSPF on R1. Okay. So command is router OSPF and then process ID. Now question is, what is process ID? So guys, process ID is nothing. See, we can run multiple process of OSPF on a router. So how you will verify multiple process? With the help of process ID. With the help of process ID. So just we are running, let's say OSPF process number 1, or we are running OSPF process number 2. This is locally significant. We can configure same process ID as well on 2 router, or we can configure different process ID as well on 2 router, right? It is not going to impact OSPF neighborship. So on both router, I can configure same process ID, or I can configure different process ID. This is locally significant. So let's say I'm going to use process ID 1 here. After that, we need to define router ID. So let me say router ID of R1 is 1.1.1, right? Just I have enable OSPF and I have defined router ID. Now to enable OSPF protocol on the interfaces, we will use network command. So network 12.1.1.0 while karma 0.0.255 and say area 0. I am advertising this interface in area 0. OSPF work on the basis of areas, or you can see on area concept. So now we are not talking about areas concept, because this is advanced things, but now we are advertising all interfaces of router 1 and router 2 in area 0 only. Okay, so I am advertising 12 network in area 0. Once I will hit enter, it will start sending hello message from fast Ethernet 1/0, because this network is running on which interface? Fast Ethernet 1/0. So once you will hit enter, first router will look up that this network is running on which interface, right? So this network is running on fast Ethernet 1/0. Router will check show IP route this command, right? And you can see 2L network is running on fast Ethernet 1/0. So it will enable OSPF on fast Ethernet 1/0. First of all, how to verify that? So for that we can run command show IP OSPF interface brief. So you can see OSPF is enabled on fast Ethernet 1/0. Which process I am running? Process 1. And this interface is in which area? In area 0. And what is the IP address of this interface? 12.1.1.1. What is slash values? 24. And what is the cost of this link? 1. And state is waiting. State is waiting. Waiting time is 40 seconds. Right after 40 seconds, we will see maybe this router will become DR or BDR. Now you can see this router is DR. Clear? In the capturing also, we can see the hello messages of router 1, that router 1 is sending hello message or not. So see, router 1 is continuously sending hello messages. We can filter the output OSPF. You can see these are hello messages. What is source IP address? 12.1 means this router 1 is sending this hello message, correct? Now, if I will open this hello message, you can see inside the hello message, router is sending what information? Router ID. It is sending message type, version, packet length, and source router ID. Source router ID. So we have not configured any authentication here. So authentication type is null and data is also none. Then we can open OSPF hello packet. So inside the hello packet, it is sending subnet mask. It is sending hello timer. By default, hello timer is 10 seconds. And it is also sending priority. It is sending, router date interval. Date interval is 4 time of Dead interval is like a hold on time. It is 4 time of hello message. DR router is 0.0.0 means unknown. BDR router is also unknown. So router is sending these information inside hello message. Okay. Now here, so IP OSPF, we can run this command to check more information. Like as I told you, by default reference bandwidth is 100. So here we can see the reference bandwidth. What is reference bandwidth by default? Reference bandwidth is 100 Mbps. Reference bandwidth is 100 Mbps by default. And bandwidth of my link. So interface F1/0 say include BIA. So bandwidth of, sorry, not BIA, bandwidth. Bandwidth of my link is also 100 Mbps. This is in kbps, so you need to divide it with 1000, so you will get 100. So bandwidth in Mbps is 100 of my link. So what is cost? Cost is going to be what? Formula is cost of formula of cost is 100 divided by 100, reference bandwidth upon bandwidth of my link. So because of that, so IP OSPF interface brief, we can see cost on this link is what? 1. If I will, let's say, change reference bandwidth, if I will set reference bandwidth 1000, router OSPF process 1 and say reference here we can check command IP okay, let me just give me 1 second. Let me check the command to change reference bandwidth in OSPF. So what is command to change reference bandwidth in OSPF? This is command auto cost reference bandwidth. So here I can run this command auto cost and reference bandwidth. Here we can say 1000. So what it's saying? OSPF reference bandwidth is changed. Please ensure reference bandwidth is consistent across all routers. It's saying reference bandwidth should be 1000 on all routers. And now here if you will run show IP OSPF process command or show IP OSPF only, so you can see what is reference bandwidth over here, 1000 Mbps. And now if I will check what is cost on fast Ethernet 1/0, so IP OSPF interface brief. So now you can see cost is what? 10, because 1000 divided by 100, cost is 10. Then we have some more, verification commands. So IP protocol, we can run this command. So IP protocol to check some information like maximum path that this router can install. By default is 4. Router ID of this router is 4.4. We are not performing any filtering for inbound or outbound. Okay, and then you can see we are performing routing for this network 12.1.1.0 network, and distance value is 110. So AD value of OSPF is 110. Right now I need to enable OSPF on fast Ethernet 0/0 also. So on fast Ethernet router OSPF, router OSPF, again process 1, and let me run one more network command 10.1.1.0 0.0.255 wildcard mask and area 0. Now so IP OSPF, so IP OSPF interface brief, you can see now OSPF is enabled on 0/0 also and 1/0 also, and cost on both link is what? Same, because bandwidth of both link is same. We are using same link, both are fast Ethernet link. But so IP OSPF neighbor, is there any neighbor of router 1? No. Why? Because router 1 is sending hello message to router 2, but on router 2 till now we have not enabled OSPF. right? And now I want to show you database of this router. So IP OSPF database. As I told you, OSPF routers are going to maintain database. So see, in this is database of R1. Inside the database, there is one LSA. And how many links are there? How many links are there? Two number of links are there, right? 0/0 and 0/1. And how router is representing the database, their LSA, with the help of router ID. Advertiser router is 1.1.1. We can open this database in detail by running command show IPOSPF database and router 1.1.1. So you can see this is detailed information of database, right? OSPF router ID. Okay, this is header. This is header information. How many links are there? Two number of link are there. Advertising router ID, link ID, sequence number. Sequence number is 3. And then if there are two link, one link is this one, link connected to a stub network. Stub network means directly connected network. And what network we are running there? What is subnet mask on that link? And number of, this is different thing. What is cost on this link? And then we have one more link connected to again a stub network. What network is running on that link? What is subnet mask on that link? And what is cost? Right? Debug IP OSPF and the packets. So like this also we can see hello message OSPF. After 10 seconds, it will send one hello message. Right? So it is sending hello message from fast Ethernet 1/0 on what multicast address 224.0.0.5. So this multicast address is reserved for OSPF. Even this router is sending hello message from fast Ethernet 0/0 also, but it should not send hello message from LAN interface, right? So simply what we can do, router OSPF 1 and passive interface fast Ethernet 0/0. Now it will not send hello message from 0/0 because I have configured that interface as passive interface. How to verify? So IP protocol. So you can see passive interface is fast Ethernet 0/0. Right. So now you can see it is sending hello message from 1/0 only, from fast Ethernet 1/0 only on this multicast address. Actually, two multicast addresses are reserved for OSPF. One is 224.0.0.5 and another one is 224.0.0.6. Okay, so till now, so IP OSPF neighbor, we don't have any neighbor. Now let me configure OSPF on router number 2 also. Before that, guys, any question? If you have any question, please let me know in chat. Otherwise, I am going to enable OSPF on router number 2. Getting my point? So, okay, fine. Let me enable OSPF on router number 2. On R2, again, router OSPF 1 and router ID 2.2.2.2.2.2.2. Then network 12.1.1.0, 0.0.255 and area 0. Guys, to form neighborship, area ID must be same. Area ID must be same. See, inside the hello message, there are many parameters, right? Routers are sending many parameters. So out of these all parameters, let me show you which parameters should be same for neighborship. Version should be same. Version should be same. Hello time should be same. Sorry. Version should be same. Router ID must be unique. Router ID must be unique. If we have configured authentication, so authentication type and authentication data should be same. Area ID should be same, right? Area ID should be same. Subnet mask should be same. Hello interval should be same. Date interval should be same, right? And then these are the parameter. for neighborship. These are the parameter for neighborship. Router ID should be unique, area should be same, hello time should be same, and date interval should be same. And now see the router ID, DR router ID is what? 12.1.1.1. DR router ID is 12.1.1.1. Actually, I have enable OSPF on router number 1 first, right? So router 1 will wait for DR and BDR election for 40 seconds, right? For 40 seconds. Here we can verify that also. Let me take you to R1. And so what we are going to check? So IP OSPF interface fast Ethernet 1/0. So I'm going to check detailed information of OSPF on fast Ethernet 0/0. So here you can see what is wait time. 40 seconds. Right? So within, if router 1 will receive a hello message with higher router ID within 40 seconds, then definitely router 2 will become DR. But router 1 have not received any hello message with higher router ID within 40 seconds. So router 1 have declared themselves as DR. And now even router 2 will come up, right, in OSPF domain with higher router ID. Router 1 will be still DR. Okay. So once one router will become DR, right, that will be still DR. Even that router will receive hello message with higher router ID. And before checking router ID, router is checking priority. So by default, actually priority is same on both routers. So that's why router can perform DR and BDR election on the basis of router ID. If you want, any router should not become DR or should not participate in DR and BDR election, you can configure priority 0 there. You can configure priority 0 there on all. And so IP OSPF interface fast Ethernet 1/0. On this interface, we can see detailed information like what is priority by default 1. What is priority by default 1? Okay, so if I will set priority 0 here, interface fast Ethernet 1/0, IP OSPF priority 0. Right now, so IP OSPF interface fast Ethernet 1/0, you can see this router is now DR other. Now this router is DR other. Now this router will not participate in DR and BDR election. Earlier this router was DR router. Right? So if you want any router that should not participate in DR and BDR election, you can set priority 0 there. Interface fast Ethernet 1/0. Again, I am going to set priority 1. Right? And now I am going to run network command 12.1.1.0, 0.0.255 and area 0. So in this scenario, which router will become DR now? Which router will become DR? So IP OSPF neighbor. Router 2 is BDR. That means router 1 is DR. So IP OSPF interface fast Ethernet 1/0. This router is DR. Let's say I want router 2 should become BDR. Router 2 should become BDR. So what I can do? I can increase some priority over here on router number 2. Interface fast Ethernet 1/0, IP OSPF priority, let's say 10, and clear IP OSPF process. Say yes. And so IP OSPF neighbor. Still router 1 is DR. Now you can see router 2 is my DR. Router 2 is DR. And so IP OSPF interface fast Ethernet 1/0. You can see guys, DR and BDR election will happen in broadcast network type only, right? So here if I will change network type between router 1 and router 2, like Here network type should be point to point because this is not broadcast network, right? So here I should change network type of OSPF. Interface fast Ethernet 1/0 IP OSPF network and say point to point. Between routers, you should always configure network type point to point. On router number 2 also I need to run this command. Otherwise, again neighborship bill goes down. IP OSPF network point to point. And now show IP OSPF neighbor. You can see now we don't have DR and BDR, election on this link. So IP OSPF neighbor. So IP OSPF interface fast Ethernet 1/0. So you can see there is no DR and BDR. State is now point to point. State is now point to point. On router number 2, show IP OSPF interface brief. I have enabled OSPF on fast Ethernet 1/0 only. So let me enable OSPF on fast Ethernet 0/0 also. So let me guys tell you another method to advertise interfaces in OSPF. How to enable OSPF on interface mode. So go to interface fast Ethernet 0/0 and here we can simply run this command. IP OSPF process 1 area 0. This command will also enable OSPF. So IP OSPF interface brief. So you can see now OSPF is enabled on both interface. And on this interface, it is waiting for DR and BDR election and it is sending hello message from 0/0 also. So I need to configure this interface as passive interface. So router OSPF 1 and say passive interface fast Ethernet 0/0. Right? And so IP OSPF database. This is database of router 1, router 2, and see so IP OSPF database router 2, router 1. Is there any difference, guys, between database of router 1 and router 2? See, database of router 1 and this is database of router 2. Database of both router is identical, same. Correct? Correct. Okay, debug IP OSPF hello and debug IP OSPF packets. Clear? IP OSPF process? Say yes. See. Let me run clear command again. One more time. See, send hello message. It have sent hello message to this address from 12.1. Means router 2 have sent this hello message. Now router 1 is also going to send hello message. Right? So it is saying receive hello message from 1.1 12.1.1.1 and received hello message, send hello message. We are able to see only hello message here. Okay, leave on all and see in the capturing. First, earlier router was sending only hello message. 12.2 have sent first update message, right? This is description message of 12.2. Again, we have some here error. Let me do one thing. Let me clear OSPF neighborship once again. Yes, now. See. This is description message of 12.2. This is description message of 12.1. Empty DBT. After that, actual DBT of 12.1, actual DBT of 12.2. Then 12.2 have sent request message. 12.1 have sent update message, 12.2 have also sent update message, and after that both router have sent acknowledgement message, right? Then OSPF neighborship will come in full state. Hope it is clear. So IP route OSPF. So router 2 have learned this network through OSPF, and so IP route OSPF. Router 1 have learned 20 network through OSPF. Now these two LAN can communicate with each other. Ping 20.1.1.1, source 10.1.1.1. Yes. Now we have connectivity between these two LAN. So IP OSPF database. Inside the database of router 1, we are able to see two number of LSA 1. This is LSA 1 actually, router LSA. This is LSA 1 of 1.1.1 means router 1. This is LSA 1 of 2.2.2 router 2. On the broadcast link, router consider their neighbor as a link. Because of that, you can see inside the LSA1 of router 1, there are how many links? 3 links. But actually we have only 2 links on router number 1. So if you will open it in detail, so IP, OSPF, database, and router 1.1.1. So you can see link connected to stub network, tactily connected network. Network is 10.1.1.0. Another link is link connected to another router. So it is considering their neighbor as a link. Neighbor as a link. Done. Now, how this router can design topology by checking their database. So let's say, guys, this topology is not in front of me. And here, through the database of R1, can I design entire topology? So yes, first of all, so IP OSPF database. So IP OSPF database. Inside the database, when router 1 will run this command, so IP OSPF database, it will come to know that my router ID is what 1.1.1. So I am a router and my router ID is 1.1.1. It is talking about R1. It is talking about R1, router 1. R1. Then how many links are there? 3. It will open this database in detail. So IP OSPF database router 1.1.1.1. Okay. So how many links are there? 3. Link connected to a stub network. A stub network is there where we are running this network, right? Okay, one stub network is here, like directly connected. As I told you, a stub network means directly connected network. One directly connected network is there where we are running which network? 10.1.1.0. What is subnet mask? 255.255.255.0/24. Right? What is the cost on this link? 10. Cost on this link is 10. 10. Right? After that, link connected to another router. A link connected to another router, point to point. Network type is point to point. And neighboring router ID is what? 2.2.2.2. Neighboring router ID is 2. Means one router is connected with me whose router ID is 2.2.2. Definitely it is talking about R2. So one router is there whose router ID is 2.2.2. This is talking about R2. R2. Then router interface IP address is 12.1.1.1. IP address on my interface where this neighbor is connected is 12.1.1.1. So IP address over here is 12.1.1.1. And what is the cost? 10. So again, cost on this link is 10. Right? Then link connected to a stub network. Where which network is running? 12.1.1.0. Definitely it's talking about network which is running between R1 and R2. Submit mask, this one, and cost, this one. Right? Right. So what network is running here? 12.1.1.0/24. Now R1 will open database of router 2 in detail. So IP OSPF database. Inside the database, there is LSA1 of router 2 also. So it is going to open the database of router 2 in detail. Right? Here also you can see router ID of this router is 2.2.2. And link connected to a stub network. Again, one link is connected with this router 2.2.2, where we are running this network 20.1.1.0. Submit mask is 255.255.255.0, and cost on that link is 1. Okay. One stub network is connected with router number 2. Where which network is running? 20.1.1.0/24. And cost on this link is 10. Then link connected to another router 1.1.1. It is talking about R1, and IP address is of my interface is 12.2. So IP address of my interface is 12.1.1.2. Then cost is 1. Then link connected to another stub network. It is talking about the link which is running between R1 and R2, because you can see network. What network is running there? 12.1.1.0. Right? Cost is again 1. So these are information inside the database. So by checking their database, a single router can design entire topology. You can see this is my topology. There is no any difference between this topology and topology in GNS3. Both are same. Correct, guys? Correct. So with the help of database, router can design entire topology. Now what next in OSPF? So IP OSPF, this router have executed their SPF algorithm how many times? 10 times. OSPF uses SPF algorithm for best path selection. SPF stands for shortest path first. Shortest path first. So whenever a change will occur in LSA1, router is going to execute their OSPF algorithm, SPF algorithm. So if I will create one loopback here, let's say on this router interface loopback 1, say IP address is 100.1.1.1 and IP OSPF 1 area 0. So I have advertised one more interface in OSPF. So IP OSPF. Now, how many times this router have executed SPF algorithm, guys? 11 times, right? And so IP OSPF database. You can see number of link in the database of router 1 is now 4. Earlier it was 3. And the sequence number of their database is 7. So whenever change will occur in this LSA, sequence number will also incremented by 1. On router number 2 also, so IP OSPF database sequence number for the LSA1 of router 1 will be same, 7. So if R2 will receive any LSA1 from router number 1 with same sequence number, it will not update their database. Now, so IP OSPF, okay. So IP OSPF interface fast Ethernet 1/0. What is hello time here? 10 seconds. What is dead time? Hold on time 40 seconds. Wait time, this one. What if I will change hello time on router number 1? Interface fast Ethernet router OSPF 1 again need to check command. IP OSPF hello interval. This is command. So on interface, we will run this command. So again, go to interface fast Ethernet 1/0 and IP OSPF hello 5. So IP OSPF neighbor. We have a still neighborship. Clear IP OSPF process say yes. Wait. Neighborship is not there. Why? How to troubleshoot it, guys? You will run this command. So IP OSPF interface brief. So see, OSPF is enabled on both interface, right? On router number 1 also you will run so IP OSPF interface brief. Brief, you can see OSPF is enabled on both interface. Then why we don't have neighborship? So IP OSPF neighbor. Why we don't have neighborship? Why we don't have neighborship? So IP OSPF neighbor. So to form neighborship, for neighborship criteria is hello time should be same. Hello time should be same. How to troubleshoot this problem? On both routers, so IP OSPF interface F1/0. Here we can see hello time is 10 seconds, and on router number 2, so IP OSPF interface fast Ethernet 1/0. Hello time is 5 seconds. This is the reason why we don't have neighborship. So on router number 1 also, so I am going to change timer. Interface F1/0, IP OSPF hello 5 seconds. Now you can see we have neighborship. So IP OSPF neighbor. Done. Yes, change it. So hello time should be same. Now on router number 1, I'm going to change, let's say, area. Interface fast Ethernet 1/0. IP OSPF 1 and area, let's say 1. Again, so IP OSPF neighbor. We don't have neighborship. So area should be also same. Area should be also same. On router number 1, sorry, on router number 2 also, interface F1/0, and we can see the log message as well. Process 1 with neighbor 1.1.1 on fast Ethernet 1/0, state move from full to down. So neighbor down. Date interval expired. Date interval expire. So IP OSPF 1 area 1. Here also I have to configure same area. Now you can see again we have SPF neighborship. And so IP route OSPF. Okay. Now you can see these are intra area prefix. Earlier, now this is inter area prefix. Earlier this prefix, these two prefix was intra area prefix. Means prefix of same area. Now these are inter area prefix. These prefixes are coming from different area. These prefixes are coming from different area. So on these interfaces also, LAN interfaces also, if I will change area interface range F0/0 and say loopback 1, IP OSPF 1 area 1. And now on router number 2, if you will check routing table, just wait. Now you can see if router have learn some prefix with O symbol, that means this is intra-area prefix. If router is learning a prefix with OIA symbol, that means this is inter-area prefix. Clear? This is still inter-area prefix because on router number 2, so IP OSPF interface brief, you can see this interface is still in which area? In area 0, and this interface is in which area? Area 1. So again, on interface fast Ethernet 0/0, I can say IP OSPF 1 area 1. And now on router number 1, if you will check routing table, you can see this is now inter-area prefix. Inter-area prefix means prefix of same area. So IP OSPF, and then we can run these all command here, guys. We can check neighbor, we can check database, we can check border router, we can use interface here, right? We can use traffic, SAM link. These are not for you. With the help of this command, we can check reference bandwidth. We can check how many times this router have executed their SPF algorithm, right? And so IP OSPF interface brief. With the help of this command, we can check OSPF enabled interfaces. And so IP OSPF interface fast Ethernet 1/0. We can check detailed configuration of OSPF on a particular interface. Now, so IP protocol. So we have some passive interface here, fast Ethernet 0/0. That is fine. Distance value is what? 110. Distance value is 110. This is by default. We can change it also. And maximum path. How many paths this router can install in the routing table? 4. So if you want to change these things, a router OSPF 1 and say maximum path 1. So IP protocol. Now maximum path is 1. This router can install only one path in their routing table now. Okay. How to change network type? Again, if I will configure network type broadcast between R1 and R2, it will perform DR and BDR election. Yes, we can communicate between two different areas as well. Yes. Router OSPF 1. And here also you can see how many commands are there. We can change distance value also, like by default distance value is what? 100. Let's say I want to set distance 200. Do so IP protocol. Now distance value is what? 200. So on router number 1, so IP route OSPF. So see, it have learned this network from router number 2. Clear IP OSPF process. Let me clear the process once. And so IP route OSPF. What is distance for this network now on router number 2? 200. 200. And cost to reach in this network is 2. Cost to reach in this network is 11. How? Cost of for let's say 10 network. So cost of fast Ethernet 0/0 on router number 1 is 10, and cost of fast Ethernet 1/0 of router number 2 is 1. So total cost to reach in 10 network is 11. So IP OSPF interface brief. Here you can see cost value is 1 on fast Ethernet 1/0, and on R1, so IP OSPF interface brief, cost on fast Ethernet 0/0 is what? 10. Right? So total cost to reach in this network, in 10 network from router number 2 is 11. But now, so IP, let's say on router number 2, so IP route OSPF. So in the routing table, we are able to see some prefixes. Now, if you want to filter this prefix, you can configure AD value what? 255. So you can configure AD value 2552. AD value is what? AD value define reliability of route, right? 0 is reserved for connected. So IP route. In the routing table, you can see for connected network, AD value is nothing, 0. For a static route, AD value is 1. For OSPF, by default, AD value is 11. 0. For EIGRP, by default, AD value is 90 and 170. For RIP routing protocol, we have different AD value. And route with AD value 255 is unknown. 255 AD value is reserved for unknown. So if you will configure AD value 255 on router number 2, these all prefixes, so IP route OSPF, these all prefixes will filtered from router number 2. Router OSPF 1 and say distance 255. And so IP route OSPF. Now you can see the routing table. We don't have any route. So IP OSPF database. Inside the database, we have prefix, 10 prefix. So IP OSPF database router and 1.1.1. You can see in the database, we have still this prefix. But router have filtered it from their routing table because here I have configured distance what 255. Here we have configured distance 255. So IP route OSPF. That's why we are not able to see any prefix. So let me change it. Router OSPF 1 and say distance 110. So IP route OSPF. Again, you can see the routing table. So if you want to filter some prefixes, you can configure AD value 255. Even you can change AD value for a neighbor, for a specific neighbor only, right? Let me tell you. On router number 2, router OSPF 1, and then distance. Here we can say distance, let's say 200, and then from a particular neighbor, IP address of neighbor 12.1.1.1, wildcard mask 0.0.0, right? Even for some prefixes also we can set AD value 200, right? We can use access control list. So what I am saying, let's say here between router 1 and router 2, we have one more path. Right, let me configure the scenario. On router number 1, config T, interface F1/1. Let me configure one IP on this interface. IP address, let's say 13.1.1.1, 255.255.255.0, say no sat, and let me enable OSPF. IP OSPF 1 area 1. Right. On router number 2, sorry. First of all, let me remove this command. No. Then interface F1/1, IP address 23.1.1.2, 255.255.255.0, say no set, and IP OSPF 1 area 1. Then go to R3, config T, interface F0/0, say no set, IP address 13.1.1.3, 255.255.255.0, and IP OSPF 1 area 1. Soon we will have OSPF neighborship between R1 and R3. Yes, you can see the log message. Now let me configure another interface, interface F1/0, IP address 23.1.1.3, 255.255.255.0, IP OSPF 1 area 1. Router OSPF 1, router ID 3.3.3. Do clear IP OSPF process, say yes, and now we can apply this command. Right. Now on R2, so IP OSPF database. Let me do one thing. Here we have, network type broadcast between R1 and R3 and between R2 and R3. So let me change network type there. Because of that, we are able to see some extra LSAs like network LSA. So on R1, so IP OSPF interface brief. So here we have DR on this link, fast Ethernet 1/1, and DR on fast Ethernet 0/0. Fast Ethernet 0/0 of R1 is the LAN interface. So IP OSPF neighbor. Okay. Config T, interface F1/1, IP OSPF network, say point, and on router number 2, interface F1/1, IP OSPF network point, and on R3, interface range F0/0 and F1/0, IP OSPF 1, OSPF network point. So IP OSPF database. Still we have network LSA from 13.1.1. from 3.3.3, clear. IP OSPF process, yes. So IP OSPF database. Now you can see the database, right? We have only a router LSA. On router number 2 also, so IP OSPF database. Here we have router LSA as well as here we are running 2 process of OSPF. So IP protocol. So IP OSPF interface brief. All are in area 1, and we have DR on fast Ethernet 0/0. This interface network type should be so IP OSPF database, clear. IP OSPF database process. Done. Right. So see, Actually, this time router 2 is learning 10 network, 10.1.1.0 network from both neighbor, from router number 3 also and from router number 1 also, right? Because if I will open, so IP OSPF database router 1.1.1. In the database of router 1 also, we are able to see 10 network, 10 network at 10.1.1.0. And in the database of router 3, 3.3.3 also, we are able to see this 10 network. Where is? So IP route OSPF, it is not learning 10 network. So IP OSPF neighbor. So we have a full neighborship here. Yes. And so IP OSPF interface F0/0. Network type over here is broadcast. No? So on R2, wait guys, so IP route OSPF, it is not learning 10 network. Yes, it is learning 10. So IP OS on R3, so IP OSPF database, so IP route OSPF. Okay, so we have now 10 network from 13.1.1.1. So on R2, now if you will check database, so IP OSPF database router and 3.3.3. So here also we will see 10 network. It should also advertise 10 network, but it is not advertising. No? Wait. Interface F1/0 says shut down for a moment. Actually, router 3 is not advertising 10 network to router number 2. I have to troubleshoot it. So IP route OSPF 10 network is here from router number 3. So IP OSPF database. So IP OSPF database router 3.3.3. Why we are not able to see 10 network here in the database of R3? Let me go to R3 and show IP OSPF database. Oh, actually, sorry. Extremely sorry, guys. We are checking database of R3. Inside the database of R3, we will not get 10 network, right? But what I am saying, R2 is learning database of router 1 from both, from two sides, from router number 1 directly and from router number 3 also. It is learning database of, on router number 2 we can run this command, so IP OSPF database. So it have a still database of router 1, it have a still database of router number 1 from which router, from router number 3, from router number 3. So IP route OSPF, we can see 10 network is reachable via 23.1.1.3, means this is IP address of router 3, right? Now I am going to up the link between R1 and R2. Interface F1/0, say no set again here. So IP route OSPF. So IP route OSPF. Now 10 network is reachable from, soon 10 network will be reachable from router 1 directly. Yes, you can see now. Now 10 network is reachable from router number 1 directly. Next stop is 12.1.1.1. It is reachable from router number 1. So what I am saying, router 2 is learning 10 network information from two neighbor, from router number 1 also and from router number 3 also. Best is via router number 1. Why best is via router number 1? Because router 2 is calculating least cost. Router 1 is calculating least cost via router number 1. Let's say I want to, receive 10 network via router number 3. I want to receive 10 network via router number 3, because now if I will trace route, 10.1.1.1 and source is, let's say, 20.1.1.1 numeric, my traffic is going via router number 1, right? Router 2 is forwarding traffic to router number 2. But what I want, whenever router 2 need to forward traffic in 10 network, it should forward via router number 3. It should forward traffic via router number 3. So first option which we have is we can increase cost on this link. We can increase cost on this link. So if I will, let's say, if I will set cost 20 over here. So cost to reach in 10 network via router number 2 is going to be what? 10 is the cost of this link and 20 is the cost of this link. So total cost is 30, and cost from this path is 10. Cost of this link is 1. Cost of this link is 1, 12. Right? So which one is best? Now lower path is best path. Let me show you practically this first. On R2 interface fast Ethernet 1/0, I can say IP OSPF cost 20. Now show IP route OSPF. 10 network is reachable. Soon 10 network will be reachable via router number 3. You can see here, right? Now if you will trace route again, this you can see my traffic is going via router number 3. Next up is 23.1.1.3. 23.1.1.3, right? This is first option for path manipulation. I have just increased the cost on fast Ethernet 1/0, right? Second option is what? Interface F1/0. I'm going to remove this command. I'm going to remove this command. Again, trace route. Wait. Now you can see traffic is going directly via router number 1. Now what is second option for path manipulation? How I can forward traffic in 10 network from router number 2 via router number 3 with the help of AD value. I can increase AD value from a particular neighbor from router number 1, right? So see how I will implement that. Router OSPF 1, and I can say distance 200 from a particular neighbor 12.1.1.1. Wildcard mask of this neighbor is this one. Now whatever prefix router 2 will receive from this neighbor from 12.1.1.1, for those prefix AD value will be what? 200. So again, if you will trace route, if you will trace route, just wait. So IP route OSPF. Distance is still 110. Okay. You will not apply this command like this. Router OSPF 1, and here router neighbor router ID. We need to define neighbor router ID. 200 for which neighbor? 1.1.1. 1.1.1 is my neighbor. 0.0.0. Do so IP route OSPF. Now see distance value is 200 from 12.1.1.1, and distance value from this neighbor from router number 3 will be what? 110. So best is via which router? Now if you will trace route again, this is problem of simulation software. Router 2 should forward traffic to router number 3 now. Right. Clear. IP OSPF process. So IP route OSPF. It's not working, right? AD value is still we are able to see AD value is 200 from 12.2, and AD value from router number 3 will be 110. So router 2 should forward traffic via router number 3 now, right? This is because of some simulation software, guys. On real devices, it will work fine. Okay. So this is basic OSPF, right? If you want to learn, again detail of OSPF, you have to enroll for paid course, right? It is not possible here to discuss entire thing about OSPF in single video. Okay. Now, guys, if you guys have any question, please ask me in the chat. This is all about OSPF. In next class, in tomorrow, I will start switching module. In switching also, we have some protocols, right? We have concept of VLAN. We have concept of trunking. We have concept of VTP protocol. We have concept of DTP protocol. We have concept of STP protocol. We have Ether channel. So we will cover these all topics in switching module. Done. So that's all for today now. If you have question, you can ask your question here in chat. What is use case of DR and BDR? Guys, DR and BDR is used to reduce unknown unicast flooding. Sorry, unknown unicast flooding note. It is used to reduce LSA1 flooding. LSA1 flooding. See, let's say I have a scenario like this. What is the purpose of loopback? Loopback is just a logical interface on router. We can create, logical. The loopback is actually used for self-testing, for testing purpose. Let's say I am on router number 2, or the one router is here connected with router number 2, that is router 4. From router number 4, we are not allow to ping this IP address or the IP address of physical interfaces. Like I am network admin, right? I'm network admin. I'm sitting here on router number 4, right? And I need to troubleshoot R1. I don't know what is the IP address running on router number 1. I need to access R1. So how I will access R1, right? I have to maintain a diary that what IP address is running on router number 1, because through IP address only I can access router, right? So when we will have lots of routers, right, we don't know what is the IP address of routers, right? For that we will have one loopback interfaces on each router. Like on router 1, we have one loopback where I'm running IP 1.1.1. I have one loopback on router number 2 where I'm running IP 2.2.2. I have one loopback on router number 3 where I'm running IP 3.3.3. Now if I need to access R1, I can access R1 through this loopback interface. For this purpose I am using loopback. Here I have created loopback for LAN, right? But in real time, we are using it for testing purpose. Now, why we come up with DR and BDR concept? See, let's say I have a topology like this. I have one switch, and here I have a router. Here also I have router. Here also I have router. Here also I have a router. R1, R2, R3, R4. So in this scenario, how many number of adjacencies are there? 1, 2, 3, 4, right? Each router have 4 neighbor, means 3 neighbor. So router 1 will have one adjacency with router number 1, one adjacency with router number 3, one adjacency with router number 3, one adjacency with router number 4. 4. In the same way, router 2 will have also one neighborship with router number 1, one neighborship with router number 3, and one neighborship with router number 4. So total number of adjacency will be 12 here in this scenario, right? So let's say if I will add one network over here, R1 will share that network information to their all neighbor, right? To their all neighbor. And now database of R2 is going to be updated. So it is responsibility of R2 to share updated information to their neighbor. So router 2 will flood that information to their neighbor, right? So like this, each router will flood same information to their neighbor, right? So to reduce this flooding, we come up with DR and BDR concept. In this scenario, if one router will become DR, so only DR will form full adjacency with all other router. Now, if let's say here I am adding one network, so this router will share their database to router number 1, and router number 1 will share it to their neighbor. So we can reduce the flooding like this with the help of DR and BDR concept. So that's why we come up with DR and BDR. Point to point or broadcast, these are network type in OSPF. These are network type in OSPF. For this, you have to understand, network type. Answer of this question is not in single word or in, sentence again. Okay, then guys, that's all for today. Let's meet tomorrow. Please, is there any way I can download switch and router? One means images. You can download images of router and switches on through Google, guys, and I can also share one link to download these devices. It depends on our scenario. Let's say we are connecting two router together, then network type should be point to point between router. If we have multiple router connected with switch, then network type should be broadcast. If one branch office is connected with one headquarter is connected with multiple branch offices, the network type should be point to multi points. So it's totally depends on our requirement. Yeah, sure, I will share it in group. Now, how was the class, guys? How was the session? This was just a basic of OSPF protocol. Basic of OSPF protocol. Otherwise, in paid class, I will take around 10 classes for OSPF. We will have 10 classes for OSPF protocol. So you can imagine how many things are there. Now, I don't know what is the price for paid course. CDP will let you know that. I'm just a trainer here. Okay, guys, then bye bye. See you tomorrow. Thank you.